This is 2005 Mechanics FRQ number 1. And yes, this is a bathroom. And for A, first, you must decide if it is a decreasing acceleration or an increasing acceleration. And it is decreasing because as the ball increases in height, the velocity decreases. So A would also decrease because F net force equals negative kV minus mg, and mg is a constant, it's just a continual force of gravity. So that means acceleration also must decrease as the velocity decreases as the ball rises. And for B, you must find a differential equation. And you know A equals dv dt, that'll give you your calculus there. So you set the net force equal to negative mg minus kv, like we did in letter A, and you set m times A, which is dv dt, equals negative mg minus kv, and you can leave it as that. And for C, you know that F net equals 0 because terminal velocity is a constant velocity. So you set the F net equal to the sum of forces, which in this case is plus kV because the wind resistance is now against the force of gravity, so it's negative mg plus kVt, which is terminal velocity, and you solve for Vt, that equals mg over k. And for D, it takes longer to fall because as it's going up and as it's going down, the distances are the same. However, as it's going up, there's two forces acting against it as the object rises, so that would take less time to get to the very top. However, as it's falling, you have mg going down, but in this case, falling down, you have mg going down and wind resistance going up, so that means it would take a little longer to fall down than to hit its peak height. And for E, obviously V naught is going to be the highest because that is the initial velocity to get the ball into the air, and it decreases in velocity as it reaches the peak height, and as it's falling, in perspective that we're looking at, the velocity is going to be negative, and it keeps decreasing until it hits the terminal velocity, and then that's when the velocity curves off and goes flat.